An alternate AC induction motor can be controlled by changing the frequency of the AC current or voltage. By changing the AC current, the magnetic field in the stator windings can be made to rotate at a different speed, which in turn will make the rotor follow suit. Voltage changes can also be used to control an AC induction motor. If the voltage is increased, it will result in a stronger magnetic field, and if decreased, a weaker field. An AC to DC motor controller is a device used to control the speed of a DC induction motor, or it is the DC motor, built-in speed controller through frequency regulation of the DC pulse step voltage. The main function of an AC to DC motor controller is to keep the speed of the motor constant despite changes in load or torque. For example, if a load is applied to the shaft of the motor, the controller will increase the supply of power to maintain speed. Conversely, if the load is removed, the controller will decrease power to save energy. In this way, an AC to DC motor controller can be used to optimize performance and efficiency while also prolonging the life of your DC induction motor. How do I choose a DC motor controller? The first consideration is the motor's nominal voltage. DC motor controllers tend to offer a voltage range. For example, if your motor operates at 3V nominal, you should not select a motor controller that can only control a motor between 6V and 9V. This will help you cross off some motor controllers from the list. What is the difference between a motor driver and a motor controller? The main difference between a motor controller and a motor driver is that the controller is responsible for controlling the speed, torque, the direction of the motor, whereas a motor driver is responsible for providing enough electrical power to the motor as required. When would you use a motor controller? Applications. Motor controllers are used with both direct current and alternating current motors. A controller includes means to connect the motor to the electrical power supply, and may also include overload protection for the motor, and over-current protection for the motor and wiring.